Hello everyone, my name is Marius, and together with my colleague Vlad, we will present you how we scale NFT collections. But first, a bit about us. We both work at Sandbox as tech lead, and we also co-founded QED, which is a software company that Sandbox trusted to get things to the next level. Our journey started 2 years ago with a team of 4 developers, and as for now, we have a crew of over 20 people, designers, developers, project manager, product owners, and so on. Our office is located in Romania, in the city of Timișoara, which is also the European capital of culture this year. So if you plan to visit, feel free to reach to us. We can exchange Telegram later, and we can show you some really cool places. Our journey in Sandbox started with Snoop Dogg NFT avatars, which was the Sandbox first official collection. This one was a really big hit, over 10,000 NFTs sold out in a couple of minutes. This generated a huge demand of Sandbox official NFT collection, but at the same time, we had to integrate pre-existing NFT collections into the metaverse. For example, we bridge Bored Apes besides other collections. So if you own a Bored Ape, you can play with that in the Sandbox. However, our previous infrastructure and tools was not capable to handle this level of demand. So we had to create our own tools and definitely upgrade our infrastructure. When we started, we had to launch one collection every 2 months, and as for now, we are launching up to 4 collections per month. This presented 3 major scaling issues. But first, let's take a step back and define what's an NFT collection into the Sandbox. An NFT collection into the Sandbox is made of 3 parts. We have the minting the app, so UI, UX. We have a smart contract, a classic ERC 721. And we have art integration, a process that Vlad will further detail. For all of these, we encounter bottlenecks. I'm a front-end developer at base, and I want to take a look in more detail on the minting the app. So the minting the app for our collection is made of 2 parts. We have the minting page, of course, used only for minting, and we have a landing page. That landing page is used by our marketing team to highlight the utility of the collection and also promote the client. In other words, this page needs to be custom-made. And by custom-made, I mean that it should follow the client branding guide. So we need custom fonts, we need custom colors, custom images, and so on. While creating more and more collection, we begin to identify patterns and mechanics that were recurring on collections. As you may see on the slide, most of the Sandbox collection follow the same layout. So we have a trailer, we have the characters, we have the character description, we have a milestone section, and so on. In order to ease the development of these pages, we extracted all the recurring components into a small UI library, a component kit, which provides us components, headless components, so without the branding look, without the styles of the brand. So this one, it provides us mobile-ready and accessible components. On top of that, it also ensures the consistency between collections. So it's using the same spacing, for example. And that's really important as there are a lot of scammers in the space that are trying to copy the collection and do malicious things. Okay. The only thing that we had to do was just use the code blocks from the UI library, and we have the page ready. Now that we can develop really fast and really cool pages, the next bottleneck that we encountered was the deployment. Because when we started, all of our collection were part of the Sandbox monolith, which is a huge web application, tons of code, a lot of legacy, and of course, a really, really lengthy release cycle. So even though we managed to create the collection really fast, we had to wait like a couple of days in order to release. To address this issue, we just extracted all the code into micro frontends, independent and autonomous, so they have their own CI, so we can deploy whenever we want. The nice thing about that is that the monolith was server-side rendered and the collections are building into static files. That means we can deploy on S3 or IPFS, depends on our needs. Now that we can create and deploy whenever we want and everything was working and scaling really nice, the only thing we had to do when creating a collection was to duplicate some code, then we changed the copy text, we set a new contract, we set a chain ID, and we were ready. But of course, that's not really fun for a programmer to do. And that's why we created a CLI tool called Create Sandbox Collection. This one was heavily inspired by Create React app. If you are a front-end developer, maybe you know that. And you can bootstrap a headless collection in a couple of seconds. So all you have to do, again, is just update the color scheme, you add the text, you set some images, you set the contract address, chain ID, and you're ready for production. You can deploy, everything's doing really nice. Okay, this one's not working anymore. Cool. Now, as developers, we were really happy about how the things are deploying, building, and so on. But definitely that was not enough because some of our users were not there. As a data-driven team, we place really great value on analyzing the user behavior, the most in the minting phase of the collection. And based on that data, we managed to find some patterns and errors that even at some point preventing the minting process. So some of our users got so frustrated that they Thank you. Cool. So the most important feature that we created and that caused a lot of frustration was the transaction history list. A bit of context, in the early days, the good old days when NFT were the cool kids on the crypto space, we deployed everything on mainnet. And the transaction resolution time was really lengthy, like you had to wait up to half an hour to get the transaction done. So the user comes to our minting page, they press mint, they see a loading spinner, nothing happens for 10 minutes, they refresh the page. That's a classic. And they see the button again, they press again, and they are creating another transaction. And at some point, they do multiple minting by fault. In order to fix that, we created a transaction history list, as you might see on the GIF. So every time you create a transaction, you see your transaction in the list. And next to the transaction hash, you see the real-time status of that transaction. So even though you refresh the page, you will see that you have a pending transaction, or maybe one that was done, or maybe one that was failed. The next bottleneck for our user was the way that we display the errors. Before upgrading, let's take an example. You are a user which tries to mint something on Polygon. If you want to mint, you need Polygon send. And you are also on a wrong chain. So you come to the page, you click mint, you see the error that you don't have enough msend, which is the Polygon send, by the way. You go to a bridge, you bridge some send, you come back, you refresh the page, try to mint again, and you see that you are on a wrong chain. That's really frustrating. And to fix that, we just proactively display errors. As you may see, if you have any error, you will see that in the box. And we also added CTAs to fix the errors in real time. So you can bridge in the page, you can change the chain by just clicking a button. As for now, we also implemented Biconomy. So before you had to own 2 tokens to mint. One to pay the gas and send to pay for the NFT. But that's not needed anymore. And also, we are doing some experiments with card payments. So we want to ease the onboarding of Web 2 user into the Web3 realms. So you will be able to mint with a credit card. Cool. Now that the minting the apps was fixed and everything was scaling really nicely, building, deploying, we encountered some bottlenecks, similar bottlenecks on the smart contract side. We had a contract, and again, we care really much about the security. So every contract in the sandbox is audited. So every time we created a contract collection, a contract for a collection, we send that to the audit. That takes like up to 2 weeks to review, and if we have feedback, we implement, send again, and until we got the green flag from the auditors. Of course, that's not really scalable, because we almost miss some of deadlines because the auditing and the contract. In order to fix that, we created a generic contract. Basically, we extracted all the common logic into a generic contract, which was audited once, and every time we create a new collection, we just extend that contract. We apply some arguments like the name, the symbol, the max supply, and we are ready for production. That's scaling nicely, but I will let Vlad tell you more about what we did next. Thank you.
Thank you. So first, I want to mention that everything we are doing on the smart contract development side is free and open source. And you can find our contracts under the GitHub repository on the Sandbox organization. We also did some open source contribution for the OpenSea registry filter to be compliant with their royalties fees. So yeah, moving forward, now this generic raffle approach works if you have a small number of collections, let's say, I don't know, 3 or 4 per year. But if you want to scale to more than 50 per year, the entire process is getting harder and harder. You need a technical person to deploy the smart contract. You need somebody to change the state, to sign transactions, so on and so forth. So for that, we deployed this new factory smart contract. And right now, we have a factory that's going to deploy the smart contract for us. So using a small back office, the app, everybody can, from our team, deploy and manage those collection states. Right, moving to the last problem, the one with art integration and art scaling. In order to create more than 4 collections per month and to be able to bridge 500,000 of avatars in 1 year, you need a separate system that can integrate, generate, and manage the avatars and the assets themselves. To give you a little bit of a context of why this problem is complex and I think I'm mixing a slide. Anyway, to give you a little bit of a context why this problem is complex and complicated, let's talk about the avatar anatomy inside the sandbox. So any sandbox assets, not specifically avatars, have 3 main components. Has the 3D model that has also 2 subcomponents. One is the GLB and the GLTF. Those are file formats open for like specific 3D stuff, really chunky, really heavy, but they can be opened and played with in VR apps, AR apps, web browsers, so on and so forth. But those files are not optimized for voxels. So we have a different file format, our own, called VXC. And this one is used mainly for our game client and game maker tools. The second component is the 2D representation of that 3D model. Basically the JPEGs that you're going to see on OpenSea, Twitter, so on and so forth. And the last one is the JSON, the metadata, the text representation of those avatars. Okay. Now, when we started this journey to create collections, there were not so many tools. And the tools that existed were really generic. You could create only PFPs and 2D images, basically. And the tools that existed on this 3D part were not highly optimized for voxels. More specifically, we have this issue on mapping a trait to certain 3D nodes from the model. In this example, you're going to see a golden bored ape. So to make this golden bored ape, you need to define a trait, let's call it skin, with a value golden. And you need somehow to map this trait to all the nodes that are affected by it. So in this case, if it's a skin, it means that every single node from the avatar is affected by the changes. More so, you also need to define a layering system on top of it. Well, it's not fun, it's not sexy, but we solve it using a spreadsheet initially, in which you can define all the tokens, their scarcity, the traits. It has a randomization algorithm. You can define the description. It has some inclusion, exclusion rules. And that's what we use, and our partner studio use that in order to generate the collection. And here you can see how we map the trace to nodes. So it's really not cool and not usable on the long run. The previous tool that you saw, the spreadsheet, outputted a package that furthermore was used by our 3D artist to model every single trait into what will gonna be avatars. Now, we take the package, we take the metadata, we run something locally with some glue scripts, Bash, Python, and we generate the entire avatar collection on our laptop. That's how was the doggy created and the first Sandbox collections. I mean, it's not nice, it's not interesting, but it worked. And it definitely won't scale. So right now, we moved everything into our cloud pipeline. This cloud pipeline is composed of AWS workflows, AWS step functions, and those step functions are gated by some API endpoints. And on top of those, we also have a small UI. So now every single operator from our staff can generate, can create collection, can regenerate their work. Here is the Paris Hilton collection being generated. First, we receive the package from our artists. We generate the 3D models really efficient in parallel using a caching mechanism. So if you change just one trait, not the entire collection is going to be generated, but just the models affected by those changes. We move forward to generate the 2D representation. Then we pack everything together, and we put it in our storage and then our ecosystem. All right, but we don't want to stop here. We want to allow everybody to use those kind of tools. And now we are in private beta with some partner studios with what we call Collection Lab. And this tool is going to allow every single creator, initially landowners, to create and generate and finally maybe sell their collection using it. You can define everything that I mentioned before and whatever Marius mentioned previously in this Collection Lab tool. Right, thank you everybody. If you have any more questions, we'll be around this. Yep.
I just wonder if you have heard about Web3 inbox messaging system that Wallet Connect developers are introducing in near future. Because when you talk about the error managing, and it comes in my mind this speech I've just heard, because they are developing a system where a user, after connecting with Wallet Connect, have a whole history of his transaction and also error happening when you buy an NFT or something like that. And so I wonder if you are reinventing the wheel, or maybe you can interface with their backend for this managing.
I think this question is more for me because I'm the UI UX guy. So I think our problem is way too specific to use a generic solution, as the problem was happening only on specific collection pages. So even though you see some hashes that failed or maybe are they have a done status. It doesn't help from a UX perspective. You need to see there maybe besides the hash, maybe if it's done, the token. So I think that solution definitely great, but I don't think that's for us because our problem is way too specific for the things we are building.
Thank you.
Welcome.
More question? No? Maybe just one for me then. That private beta you were talking about looked very interesting. When are you planning to release to a wider audience?
So we are developers, not necessarily product guys. But,
of course.
but in 2 weeks, we are going to open it to 10 studios, partner studios that we are working with. And hopefully by Q1 2024, we're also going to have the launchpad and everything connected. Like you can create, then deploy the smart contract using the factory, and generate the collection itself.
Okay, thank you. Thank you, makes sense. And out of the many collections you made throughout the years, what's the one that's most exciting for you? Just a general question out of curiosity.
I think the people of crypto was the most exciting because we had a personalization feature. So it was a concept of dynamic NFTs. You could personalize your avatar, so the NFT.
For me, the Agoria one. We have another collection called Agoria in the same spirit, but and each 6 hours your avatars are changing. And that's the concept of dynamic NFTs, and it's pretty cool to have your avatar change also inside the game.
That's brilliant. Any more questions? Yeah, one for the audience.
Hey, yeah, nice presentation. I have a question is, usually NFT connections is also about community building, because you are giving an infrastructure right now for any NFT to any developers or companies to make their own collections. What is Sandbox role in terms of community building or beyond just collections?
Yeah, it's a nice question. We provide this infrastructure, as you mentioned, but also, so first I think there are two different types of NFT collections. One are big brands that are coming to us, they don't know how to do it or they want to learn how to do it, and then we guide them into building their community inside Sandbox. And we also have existing communities, like existing, I don't know, Cool Cats, Bored Apes, so on and so forth, that are coming to us. So using that launchpad, we want to provide the tools for them to grow and for everybody, as you mentioned, to create new communities. I'm not sure what's the plan. I cannot talk for the company, just my ideas. But for sure, we want to grow this community part and maybe offer even more tools in the future, depending on the needs of specific communities.
Any more questions? No? Then a big round of applause for our friends from Sandbox.
Thank you.